Okay, and we're back. Welcome to another Let's Code. This is Brennan Harris, and let's start up where we left off last time. In the last video set, what we had actually done was create a little script here. We had a function and a script that essentially takes these nodes and will align them up. The bottom left corner with the top right corner of another group of nodes. So these nodes are now being positioned relative to each other. So we can go ahead and just grab our groups up again, run the tool, we'll see what we actually get, and then we're going to pull this into our editor, and then we will work it up to make it fancier and take essentially the principle here and begin to apply it to a lot of different things that we can now do with our script. So yay, that's what we've got. Let's take our code, pull it into Vim, and let's start looking at ways of making it better. Now first off, this getBounds function, this is where I want to start. So one of the things I really dislike with some APIs is how they hand back things that are not useful unless you know exactly what is inside of them. And in this instance, getBounds is just returning a nested list. So it's a list of lists basically. And this is not as intuitive to look at. So let's take a function where we did this. We went and got our bounds here, and then look at this math happening here. You don't really know what's going on because, I mean, how would you actually know that 0 is x and 1 is y unless you knew about the function that was returning that value? So let's make this cleaner. I'm going to return a dictionary and return. We'll actually create a default dictionary. So what we'll do is we'll have our bounds, which before was just a list, and we're going to make it a default dict. This is going to mean, oh, actually I already have it pulled in, and I don't know why. I guess I was going to do this before and didn't do it, but here we go. We'll use a default dictionary. Default dictionary means that I won't actually have to check for the existence of a key to then make it a dictionary. So that just makes it easier to work with. So we're going to have a default dictionary of dictionaries. So for each node we get a hold of these pieces of information. Yay. And then down here we'll go bounds x min is equal to min x. Oh wait, we did need our x and our y. Y. And max is max. There we go. Now we have, oh, max. There we go. Turn bounds. Now we've got something that when you go to access it, I will know, oh, I'm grabbing the x value. Oh, and I'm grabbing the min x value. It makes it easier to look at when we're reading. Oops, did not mean to do that. Alright, so now we've got that bounds function. Now let's look at how we actually want these to work. We don't want to necessarily work by snapping corners around. That's not going to be as I guess, as useful. We would have to write more functions. So let's instead write something that works only in one axis. So we'll actually be working off of the sides. Like this side, or the top and and the bottom. We'll come up with a system so that we can actually kind of mix and match these. So we can do something like say, hey, actually I want to offset these nodes from the top of these nodes, and then I want them to be aligned in X, or I want them to be aligned, or I want them to be offset from the right side. Something like that, where we can kind of mix and match it. We'll have two function calls to kind of position the nodes, but it'll give us where we can kind of have a variety of methods to call. So let's do it one axis each. So let's we'll create these functions. We'll call them offsets. So we'll have offset right. We'll have our target nodes, where we want the nodes that we're going to be using to position ourselves relative to, and we'll just have the nodes that we're going to be working with. All right. Now we'll get our target. Let's get our stuff. Target bounds is equal to get bounds of our target nodes. Yay, we've got all this worked out. Offsetting to the right means that we're going to, and here's what I mean when I say that. When I say offset to the right, I mean that the target nodes, we're going to be offsetting the nodes from the target nodes on its right side. So we'll want to move the nodes like this. And also as part of this function, we'll give it an offset value too. So that way they won't be right on top of it, but right up against it, but will instead be some number of pixels pushed off from it. Alright, so we've got our bounds. Now we're actually just going to need, for this calculation, we're going to want, let's go back to Nuke, sorry. We're going to want the maximum x value from our target nodes and our min x value from the nodes that we're going to be moving. So let's get a hold of that information. So we'll go our target x is going to be equal to our target bounds x max. That is a lot easier to look at, and it's easier to understand. I don't have to remember any of that stuff. And we'll just call the other one x, and that's going to be its x's min. Now we need to subtract our take our target x and subtract the source x. I want to call these nodes something different just because it's kind of confusing. I might want to call them source nodes or something, but we'll get to that. We can always change function names later. Okay, this is going to be our movement x. Yeah, let's see. Call that just tx. So we've got our movement x now. Now we need to loop over our nodes for our node in nodes. There we go. And I don't need any of this now. Oh wait, we do want to have a set value. Throw all the rest of this away because we don't need it anymore. Get a hold of our x position. We then create ourselves a new x position, which will be plus whatever our movement x is. And let's make sure that's actually what we want. Yes, we want it to be a plus because we want to continue to move it to the left. And we'll add the offset to it. And that should be our offset right function. Let's try this out. Let's clear all this out because we don't need it. Well, we will need our node selection still. G1 and G2. Now let's import our module node position to reload it, in case we need to debug. Now node position dot offset right. G1, actually G2 and G1. Wait, how did it get G2? Ooh, let's actually figure out which one of these is which. I might have messed this up. Ah, G1 has, okay. There we go. Yeah, so there's G1, G2, G, there we go. My bad. Let's put these right here back over. Wait, what's happening here? G1, G2, and I'm looping over nodes, which is G2. When I do my movement, there we go, and it's offset at 20. Yay! All right, now let's take this function and we're going to turn it into a bunch of other functions because now the basic work is done. Now we just need to kind of shift it around a bit. Let's say if we want to offset left, we want to reverse these. We want to actually grab the what do we got here? We want to grab the min and we want to grab the max here. And instead of adding our offset, we want to subtract it. Let's try that one out now too. Just make sure that we're getting our stuff right. Offset left. There we go. We got offset left. top and bottom is essentially the same thing, but we're going to be working in Y. Offset top. We'll do all this. We're going to be working in Y now. Oh. Search for X, replace with Y. Wait. Except the word max. Alright. There we go. We got our new movement Y. Do that. We want to, if we're going to be putting it on, oh wait, we need to look at this. If we're going to be doing it on the offsetting off the top, we want the minimum, yes, from the target, the max from that, yes, that's fine. And then we want to add, or we want to subtract? We want to subtract because we want it to move up as opposed to down. That's our top, and let's just go ahead and knock bottom out. No reason to not just bang that one out too. Bottom, once again, flip these, and we want to add our offset instead of moving it. And just for me being silly, we'll just go ahead and add our return statements actually. And that's just status code 0. If we returned any other number, we could have status codes. Let's do offset top. Offset top, there we go. And offset bottom. There we go. And if we wanted to test it, we could give it an offset value of 0 to then actually have it line up exactly. Alright, yay. So now let's really quickly, let's do something that's actually not just a copy paste function. It's going to be, let's make it so we can center these nodes. We can take these nodes and then center them right in the middle. So same thing, let's go align center. And this one we're going to take also an axis, because this one will work for X and Y. And we'll default it to our center in X. Get a hold of our bounds, we're all good there. Let's call it our target, and just make that in target bounds. We want to pass in the axis. Okay, so here's what we're actually going to want to do with this. I've only got 3 minutes left, so I might push this off to the next video or just extend this video just a little bit. But what we're going to want to do is we're going to want to grab our min, our max. We want to subtract our min from our max, and that will give us this width. We then divide that in half to get the center point, add that to our min position to get our middle position, and then do the exact same calculation we've been doing. So let's go ahead and do that now. So we want to get a hold of what that actual position is. So we're going to need to take our max and subtract our min. And that will give us what our width is. Actually, we'll do this and then divide it by 2. And t-bounds, axis, plus this whole thing. That will be essentially what our mid position is. End position is going to be the same thing, but let's search for t-bounds, replace it with bounds. Yay, we got the same thing. Yep. T minus n will give us our movement vector. And this is going to be kind of the only lame part. We're going to have to go, hey, if axis equals x, then we want to work in, let's say our knob equals xpos. Actually, we'll just assume it's xpos because that's the default, and then we'll say, hey, if it's actually equal to y, then we'll do ypos. So we'll say our position is our knob. Say grab the hold of the knob's value to get hold of our position, our new position. It's going to be equal to our movement plus our position. We won't do an offset value here because there's no reason to offset from center is kind of weird. Alright, so we have our new position. Knob, set value to our new position, and we should be good. Let's actually see if this, I won't call it offset center, we'll say align center. There we go. Let's test it real quick. We don't have to pass any arguments because it defaults to X. There we go. Snap. Now that's done, and let's do different axis. There we go. Boom. It's now been centered up with it. So there we go. That's just in a few short minutes we've been able to take whatever we've roughed out in our last video and turned it into some actual super usable functions that are pretty clear and concise. And in our next video, what we'll actually do is we'll continue this a little bit. We'll make a few new functions that can do some slightly different things, like actually putting the nodes essentially in the same place, or putting them kind of within a particular offset into the nodes. There'll be some things that we'll actually do here. So hopefully this video is useful, and the next video we'll do some more cool stuff. So thanks for watching.